pile up the sand, but then a wave comes and washes it away. This is because the sand is loose and unstable. Soil stabilization is like giving your sandcastle superpowers. It's all about making soil stronger and less likely to erode or change shape. Soil stabilization is important in many fields, especially agriculture and construction. Just like a strong foundation is important for a house, stable soil is crucial for growing crops and building roads, buildings, and other structures. Without it, our structures would sink, tilt, or even collapse. Soil stabilization helps us create a firm foundation for our activities. Whether we're growing food or building homes, stable soil is essential for success. In the following sections, we'll explore different methods used to achieve this stability and uncover the fascinating world of soil engineering. Physical methods of soil stabilization are like giving the soil a good workout. Just as a good exercise routine strengthens muscles and improves overall fitness, these methods enhance the soil's ability to support structures and withstand various stresses. These techniques involve rearranging or adding materials to the soil to improve its strength and stability. By modifying the soil's physical properties, we can make it more resilient and capable of bearing heavy loads. This is crucial for construction projects, road building, and even agricultural applications where stable ground is essential. One common physical method is compaction. Compaction is a process where the soil particles are pressed together, reducing the spaces between them. This increases the soil's density and its load-bearing capacity. Imagine jumping up and down on a trampoline. The springs compress and become firmer. This analogy helps us understand how compaction works. When the soil is compacted, it becomes more solid and less likely to shift or settle. Similarly, compaction involves using heavy rollers or vibratory plates to squeeze out air pockets in the soil, making it denser and more stable. This process is essential for creating a firm foundation for buildings, roads, and other structures. This is like packing a suitcase tightly. The more compact the soil, the less likely it is to move. Just as a well-packed suitcase prevents items from shifting during travel, compacted soil provides a stable base that resists movement and settling. Another physical method is the use of stone columns. Stone columns are vertical columns of compacted gravel or crushed stone that are inserted into the ground to improve soil stability. Think of these as giant straws inserted into the ground. These columns act as reinforcement, much like the steel bars in reinforced concrete, providing additional strength to the soil. These columns, made of gravel or crushed stone, provide drainage and reinforcement, preventing the soil from collapsing under pressure. They also help to distribute loads more evenly, reducing the risk of uneven settling. It's like adding pillars to support a roof. The stone columns help distribute weight and prevent sinking. By providing a stable framework, they ensure that the structures built on top remain secure and level. Physical methods are like the heavy lifters of soil stabilization. They provide immediate strength and support. These techniques are often used in combination with other methods to achieve the desired level of soil stability. By directly altering the soil's physical properties, these techniques create a solid base for construction and other applications. Whether it's for building skyscrapers, laying down highways, or preparing agricultural land, physical soil stabilization methods play a crucial role in ensuring the longevity and safety of the structures we rely on every day. Chemical methods of soil stabilization are like adding glue to the soil. These methods are essential in construction and agriculture, where the stability and strength of the soil are crucial for the success of various projects. By using chemical stabilizers, we can transform weak and unstable soil into a robust and reliable foundation. These techniques involve mixing chemicals into the soil to bind particles together and improve its strength. The process can be done manually with simple tools like shovels or with advanced industrial equipment, depending on the scale of the project. The goal is to ensure that the chemicals are evenly distributed throughout the soil to achieve maximum effectiveness. One widely used chemical is lime. Lime has been used for centuries in construction and agriculture due to its ability to improve soil properties. It is readily available and cost-effective, making it a popular choice for soil stabilization projects. When added to soil, lime reacts with clay particles, causing them to clump together. This reaction is particularly beneficial for clayey soils, which are prone to swelling and shrinking with changes in moisture content. By stabilizing these soils, we can prevent issues such as cracking and uneven settling. This process, known as flocculation, creates a more stable structure that is less prone to shrinking or swelling with changes in moisture. Flocculation helps to improve the load-bearing capacity of the soil, making it suitable for supporting structures like roads, buildings, and bridges. It's like adding cornstarch to thicken a sauce. The lime helps bind the soil particles, making it more resistant to changes. This analogy highlights the simplicity and effectiveness of using lime as a soil stabilizer. Just as cornstarch thickens a sauce, lime thickens the soil, enhancing its stability and strength. Another common chemical stabilizer is cement. Cement is widely known for its use in concrete, but it also plays a crucial role in soil stabilization. When mixed with soil, cement forms a strong and durable binder that significantly enhances the soil's properties. Similar to its use in concrete, cement reacts with water to form a hard, durable binder. This reaction is essential for creating a solid mass that can withstand various environmental conditions. The cement-soil mixture becomes a robust material that is less susceptible to erosion and compression. When mixed with soil, cement creates a solid mass that is resistant to compression and erosion. This makes it an ideal choice for constructing foundations, pavements, and other structures that require a high level of stability and durability. The cement-stabilized soil can support heavy loads and resist environmental stresses. This is like turning the soil into a rock-solid foundation. The cement binds the particles tightly, creating a strong and stable base. This transformation is crucial for ensuring the longevity and safety of construction projects. A solid foundation is the key to preventing structural failures and maintaining the integrity of buildings and infrastructure. Chemical stabilization is like adding a secret ingredient to a recipe. The chemicals react with the soil to create a more stable and durable material. In a laboratory setting, various chemicals can be tested to determine the most effective stabilizer for a particular soil type. This scientific approach ensures that the chosen chemical will provide the desired improvements in soil properties. By altering the soil's chemical composition, these techniques provide long-lasting strength and improve its engineering properties. The treated soil exhibits enhanced load-bearing capacity, reduced permeability, and increased resistance to environmental factors. These improvements are essential for the success of construction projects, agricultural practices, and environmental conservation efforts. Chemical soil stabilization is a powerful tool that helps us build a more stable and resilient world. Biological methods of soil stabilization are like inviting nature to the construction site. Instead of relying solely on mechanical or chemical means, these methods leverage the natural processes and organisms that have been stabilizing soil for millions of years. By integrating plants, microbes, and other biological elements into construction and land management practices, we can create more resilient and sustainable environments. These techniques use living organisms, such as plants or microbes, to improve soil structure and stability. Plants, with their extensive root systems, and microbes, with their ability to produce binding substances, work together to enhance the soil's physical properties. This symbiotic relationship not only strengthens the soil but also promotes a healthier ecosystem. One example is phytoremediation, which utilizes plants to stabilize soil. This method is particularly effective in areas contaminated with heavy metals or other pollutants. The plants absorb and sometimes even transform these harmful substances, making the soil safer and more stable. Over time, phytoremediation can restore the health of degraded lands, turning them into productive and safe areas for agriculture or development. Certain plant species have deep roots that act like anchors, holding the soil together and preventing erosion. These roots penetrate deep into the ground, creating a network that binds the soil particles. This not only prevents the topsoil from being washed away during heavy rains, but also helps in maintaining the soil's structure during dry periods. These roots also absorb excess water, reducing the risk of landslides and soil saturation. In areas prone to heavy rainfall, the presence of such plants can be a game changer. By absorbing and storing water, they reduce surface runoff and the likelihood of floods. This natural water management system is not only effective, but also cost-efficient compared to artificial drainage systems. It's like having a network of tiny threads holding the soil in place. The plant roots provide natural reinforcement and improve drainage. This intricate web of roots ensures that the soil remains compact and less prone to erosion. Additionally, the improved drainage helps in maintaining the right moisture levels in the soil, which is crucial for the growth of other plants and microorganisms. Another biological method involves using biopolymers, which are natural substances produced by microorganisms. These biopolymers have unique properties that make them ideal for soil stabilization. They can bind soil particles together, increase the soil's resistance to erosion, and even improve its water retention capacity. These biopolymers act like glue, binding soil particles together and improving its strength. When applied to the soil, they create a cohesive matrix that enhances the soil's structural integrity. This makes the soil more resistant to external forces such as wind and water, which are common causes of soil erosion. Some biopolymers even have water-absorbing properties, making the soil more resistant to drought conditions. In arid regions, this can be particularly beneficial. By retaining moisture, these biopolymers help in maintaining the soil's fertility and support the growth of vegetation even during dry spells. This not only stabilizes the soil, but also promotes a greener and more sustainable environment. It's like adding a natural adhesive to the soil. The biopolymers enhance its structure and water retention capacity. This dual benefit of improved structure and moisture retention makes biopolymers a versatile tool in soil stabilization. They can be used in a variety of settings, from agricultural lands to construction sites, providing a natural and effective solution to soil degradation. Biological methods offer a sustainable and eco-friendly approach to soil stabilization. Unlike chemical methods, which can have harmful side effects, biological techniques work in harmony with nature. They enhance the soil's natural properties without introducing toxic substances, making them a safer and more sustainable option for long-term soil health. By harnessing the power of nature, these techniques improve soil health, enhance biodiversity, and provide a long-term solution for soil stability. They create a balanced ecosystem where plants, microbes, and soil work together to maintain stability and fertility. This holistic approach not only addresses the immediate issue of soil stabilization, but also contributes to the overall health and sustainability of the environment.